Okay, dear students, all of you know we are discussing the problem based on increasing and decreasing function. Very important application of the derivative. Okay, and here a function is given. We have to find out the intervals. A function is given. We have to find out the intervals in which interval the function is strictly increasing and the function is strictly decreasing. Understand? Let's see. So a function is given fx is equal to x square plus 2x minus 5. Let us find out slope of the function f dash x by finding the derivative of the function. So derivative of fx is equal to x square, derivative is 2x plus 2. Understand or not? Okay, now you have to equate the derivative 2x plus f dash x must be equal to 0. Let us equate f dash x to 0. Then 2x is equal to how much? Minus 2. Okay, then x is equal to minus 1. X is equal to minus 1. Here the point, the domain, you see here the real number x is equal to minus 1 divides the real number line, divide the real number line into two disjoint intervals, into two disjoint intervals. Okay, two disjoint interval. Is it clear? Now you see here, this is the real number line and this is the value is 1 minus 1. This is divided into interval into two disjoint set, two disjoint interval. One is minus 1 minus infinitive, another is minus 1 infinitive. Yes or no? Okay, two intervals. One is minus infinitive minus 1 and another one what? Minus infinitive and infinitive. Two intervals we are getting. So this real number line is divided by x is equal to minus 1 into two disjoint interval. So in the interval, now when the domain of the function lies between the interval minus n to minus 1. Let us see. Okay, minus, it means suppose you are taking minus 2, suppose. Let's see, x value is minus 2. Let us take any values in the interval minus infinity to minus 1. Okay, understand? You will see then what is the slope of the function? Slope of the function what? If you are putting the values x is equal to minus 2, it will be minus 2, this will be minus 4 plus 2, which is minus 2 is less than 0. And we know that since the slope of the function is less than 0, the function is what kind of function? Strictly decreasing function. Yes or no? Hence, the f is strictly decreasing. If the slope of the function less than 0, then the function f is strictly decreasing function in the interval minus infinity to minus 1. Very simple. Yes or no? Similarly, when x lies in the interval minus 1 and minus infinity, then f dash x. So minus infinity minus 1, we can take the values, we can take any value more than minus 1. Suppose I can take 2, suppose x value 2. Or I can take x value, any value. Take any particular domain, x is equal to 5. If I take x is equal to 5, then f dash x is equal to 5 to the 10, which is positive value and greater than 0. Okay, since the slope of the function is positive, that implies f is strictly increasing. F is strictly increasing in the interval minus 1 infinitive. Understand or not? Thus, the function is strictly increasing in the interval minus infinitive to minus 1 and strictly decreasing. The function is strictly decreasing in the interval, not increasing in the interval, because you see f dash x less than 0. So in the interval, the function is strictly decreasing minus infinity to minus 1 and here the function is strictly increasing in the interval, okay, minus 1 to infinity. Okay, this is how you can find out a function in which interval the function is strictly increasing and the function is strictly decreasing. Okay, understand? Okay, let us see and let's follow. So dear students, in this class I am discussing the problem based on the increasing and decreasing function, okay, based on the concept of application of derivative, okay, from your NCERT book standard 12 mathematics. Here I am discussing question number 6 second bit, okay, exercise 6.2. okay, in the previous class we already discussed exercise 6.2 question number 6 first bit. Here question number 6 second bit I am discussing. In this question, okay, it is given that we have to find the intervals in which the function is strictly increasing and intervals in which the function is strictly decreasing function. Okay, in which intervals the function is strictly increasing, in which intervals the function is strictly decreasing in the set of real number. Okay, understand? The function is given here. Here the function fx is equal to 10 minus 6x minus 2x square is given. Understand? So to find out the increasing and decreasing function, we have to find out the derivative. Okay, so derivative of the function f dash x is equal to, okay, it will be minus x minus 4x. Understand? Now let us equate the derivative of the function to 0. Now f dash x is equal to 0. Let us equate f dash x is equal to 0. That implies minus 6 minus 4x is equal to 0. That implies 4x is equal to here minus 6, understand, and x is equal to minus 6 upon 4 or minus 3 upon 2. Understand? Here the domain, here the real number x is minus 3 by 2, divide the real number line. So here you divide the real number line into two design set. Here is minus 3 upon 2. Okay, divide the real number line into two design set. What is one interval is two design interval. One is minus infinity minus 3 by 2. Another is minus 3 by 2 infinity. Understand or not? So in the interval minus infinity minus 3 upon 2 and minus 3 by 2 infinity. Understand? Okay, we are getting two design interval. And in this interval, we have to find in which interval the function is strictly increasing or in which interval function is strictly decreasing. Understand or not? Okay, so when you say when x belongs to minus infinity minus 3 upon 2 in this interval, okay, let us say number, suppose I will take a number, it is minus suppose 7 upon 2 I will take, okay, which number lies between minus 3 by 2 and minus infinity. So let x is equal to minus 7 upon 2. Suppose let x is equal to minus 7 upon 2. Understand? Then what is putting the value in the derivative of the function f dash x? Okay, we shall get the slope of the function. Okay, minus 6 minus 4 into minus 7 upon 2. And you see minus 6 minus minus, you see is equal to 14 and it is 8. Though is greater than 0, that implies the slope of the function f dash x is greater than 0. So if the slope of the function is greater than 0, according to the definition, okay, the function is strictly increasing function. Hence the function f is strictly increasing. Hence function is strictly, yes or no, increasing in the interval minus infinity and minus 3 upon 2. Understand? Is it clear? First one you got. Okay. Similarly, when coming to the next interval, when the x lies in the interval minus 3 by 2 to infinity. Okay. Let's see. Okay. Now let's see x is equal to minus, let in the interval when x belongs to minus 3 by 2 infinity. Okay, let's take a value it is suppose x is equal to, we can take the number lies between minus 3y to infinity. It means this value can be taken also. Suppose I can take 3. Suppose 3. Okay. And then what is the value of f dash x? So f dash x is equal to minus 6 minus 4 into 3. And this is minus 6 minus 12 minus 18. This is minus 18. And less than 0. That implies f dash x is less than 0. It means the slope of the function is less than 0. Since the slope of the function is less than 0, okay, understand? Since in the interval f dash x is less than 0, hence the function is strictly decreasing, okay, strictly decreasing in the interval what? Minus 3y to infinity. Understand? Thus we got the f is strictly, thus we got f is, hence f is strictly, so in this interval the function is what? Strictly increasing, and in the interval function is what? In the interval function decreasing. Understand or not? So the function is strictly increasing. Which interval? In which interval? Minus infinity to minus 3 upon 2, and strictly decreasing, and strictly decreasing in the interval minus 3y to infinity. Okay, understood? So this is how you have to find out, and the intervals in which intervals the function can be strictly increasing and the function can be strictly decreasing. Okay, understood? Just to follow it. Thank you. Students, in this problem I am discussing question number 6, third bit, okay, based on the concept of increasing and decreasing function of your NCERT book standard 12 mathematics, okay, exercise 6.2, based on the concept of application of derivative, okay. And here a function is given, we have to find out in which interval the function is strictly increasing and in which interval the function is strictly decreasing, okay. Here is the function is given that the function is that fx is equal to minus 2x cube minus 9x square minus 12x plus 1. Understand? So before finding the increasing and decreasing function, you have to find out the slope, okay. So by finding their derivatives, yes or no? So f dash x is equal to, it will be minus 6x square, and it is minus 18x minus 12, right? So this is equal to minus 6 being a common, x square plus 3x plus 2, and minus 6 whole into, it will be x plus 1 and x plus 2. After finding the you see after factorization we will get, okay, f dash x is equal to minus 6 whole into x plus 1 whole into x plus 2. Now equate the derivative of the function is equal to 0, and understand, okay. And this is a point where the function is divided into different intervals. In order to find the different intervals, let us equate the derivative of the function f dash x is equal to 0. Then x plus 1 whole into x plus 2 is equal to 0. Understand? Then after that x will be minus 1 and minus 2. Now the real number minus 1 and minus 2 divides the real number line. Let us draw a number line, students. So this number is minus 1 and minus 2, and this is what? Minus infinity and plus infinity. Yes or no? So the real number x is equal to minus 1 and minus 2 divides the real number line into 3 design interval. One is minus infinity minus 2, another is minus 2 minus 1, and third interval is minus 1 infinity. Yes or no? Yes or no? In the interval, this is the interval 1, first interval, and second interval, and third interval, okay. So here we got I1. Here I1 interval, first interval is what? Minus infinity minus 2, and second interval I2 minus 2 minus 1, understand, and third interval minus 1 infinity. Let's see in this interval, in which interval the function is strictly increasing or strictly decreasing. Okay, so when you say when x belongs to the first interval minus infinity minus 2, okay, let's suppose a number, let us take minus 2 minus 3, let's take a number that is, suppose I will take minus 3, suppose take. So let's x is equal to minus 3, let x is equal to minus 3, let x is equal to minus 3. If I am taking x is equal to minus 3, putting the value, and the slope of the function will be what? This sign is negative sign, you see, and here this sign will be minus 3 plus 2, it will be also negative sign. Yes or no? Okay, here you see, if you put x is equal to minus 3 plus 1 is minus 2, negative, and here minus 3 plus 2 is also negative. So what are you getting here? What are you getting here? So this overall sign will be negative, hence the function is less than, f dash x is less than 0, thus f is strictly, if the slope of the function is less than 0, yes or no, the function is decreasing function, hence f is strictly decreasing in the interval minus infinity to minus 2. Is it clear? Now let's the second interval. In the second interval, you see when x belongs to minus 2 to minus 1. Okay, suppose this value, let us take a value. So this value in this interval function is strictly decreasing. Let us write first interval. Let us take a value. This is minus 2 minus 1. You take minus 3 upon 2. Suppose take minus 3 upon 2. Yes or no? This value is minus 3 upon 2. Let us take. Okay, so let x is equal to minus 3 upon 2. In this interval, what happened? Let's see. Okay, and you see minus 3 upon 2, we can write also minus 1.5. Then you see the f dash x, put the values in the derivative of the function. This sign is negative. Here minus factor is first, minus is a factor. Here minus 1.5 means this factor is also negative, minus 1.5, and here minus 1.5, this factor will be positive. So the overall sign will be positive. It means the function is f dash x is greater than 0. That's why, hence the f is strictly increasing in the interval minus 2 minus 1. Is it clear? So this function here in the second interval I2, the function is strictly increasing. Is it clear? Now let us the third interval. In the third interval, when the domain of the function lies between minus 1 infinity. Okay, minus 1 infinity means we can take, suppose the value will be, suppose this value, suppose 7. Let us take 7. Okay, now you are getting now f dash x. F dash x means, you see, now f dash x is equal to minus 6 whole into x plus 1 whole into x plus 2. Here minus sign, negative. Again 7 plus 1 is also, 7 plus 1 is positive, and here 7 plus 2 is positive. It means overall sign is negative. Negative means less than 0. Since f dash x less than 0, so f is strictly decreasing in the interval minus 1 infinity. Is it clear? So here the function is strictly what? Decreasing. Understand? Thus we get in the interval, here you get what you get. In the first interval the function is strictly decreasing. In the second interval the function is strictly increasing, and in third interval the function is strictly decreasing. Understand or not? Okay, is it clear? So this is how you can find out whether the function is strictly increasing and in which interval it is increasing, in which interval is strictly decreasing. Understand? Okay, by finding the derivative. So important parts of derivative we can understood. Okay, the derivative is an important application to find whether the function is increasing or decreasing, and also is an important part of calculus. Okay, so thank you.